times height delta x times f of xi from I equals 1 till the last subinterval. And there is another way of calculating this. Exact. Again, exact area, no approximation. This is exact. These two symbols will be condensed into one. It will be normal S, but stretched S. As you remember, we calculated all this on a particular interval, and this interval was from 0 to 400. We're going to call that interval a comma b. So it's the integral, and I will write definite integral from a to b, and this is the same, f of x dx. Now it is written like that because that's the symbol of integral in front, and it has to be, I cannot put the function at the end. But here it's base times height. But here it has to be f of x dx. It doesn't matter really, twist it around, it's the same thing. So this is the definite integral from a to b, which exactly gives us this, but in a much faster way. Much faster way. But now I have to explain how we calculate this. We know how to calculate this as long as we have a limit in front, and that will be exact. But now how do we calculate this, which is much easier than this? Okay. Exactly what we did with derivatives. We use a definition, but then I showed you differentiation rules. Okay. So here is the way we calculate definite integrals. And I think I'm on page 9. Okay, it's called the fundamental theorem of calculus. It has two parts. We're going to talk about one of them, the one that teaches us how to calculate this. So the definite integral from a to b from f of x dx is a number. So I'll put in parentheses here. It is a number, always. The answer of a definite integral is always a number. What did we say the antiderivative? You probably didn't get the chance to look at chapter 4, so I'm going to say it. The definition or the notation for the antiderivative is uppercase f of x. A vertical bar from a to b. What's all this? What does this mean? Okay. So remember we started tonight with my example to find the area under f of x equals x squared. Okay? On the interval 0, 2. Okay. So this is the area, the exact area, which is the integral from 0 to 2 from f of x dx. dx is the same base times height as x squared. Can anyone tell us what is the antiderivative of x squared? We had it today on a previous example. What is the antiderivative? Which function I differentiate to get x squared?
X, the third over.
Excellent. From a to b, from 0 to 2. Okay. Now I'm ready to explain what this means. It's the function evaluated at b minus the function evaluated at a. So then, I keep 1/3 in front, I plug in 2, and I subtract when I plug in 0. I shouldn't even write this, but I want you to see it. 2 to the third is 8. 8 divided by 3 is the exact area with no approximation whatsoever. That's why Where is it? We had three numbers right here. 8 divided by 3 is 2 point something. That's why the midpoint was the best. The rightmost point was the furthest away, and 1.75 was better. So this is the midpoint. You have all three methods. You can use the one that you want for the left, right, or mid when you're asked to do that. But when you're asked to find the exact area, we will evaluate definite integrals. Okay, let's practice definite integrals now. Let's say 36 on page 390. The integral from 0 to 5 from 2x plus 5 dx. Everything is the same, it's just it's a different function and a different interval. Forget about the interval right now. What function prime is x? You mean x squared over 2?
Yeah, over 2.
Good. What function prime is 5?
5x.
That's it. From 0 to 5. Of course, I'll simplify. I will plug in 5 and then subtract when I plug in 0, but I get 0. 0 here is nothing. So 5 in here, 25, plus 5 in here, 25. The answer is 50. Much easier. Much easier. Now I can go back to their integrals on in section 4.1.
I had a question.
Yes, anything, please.
Just to be clear, the formula that you put up for the integral, it's like the most accurate way to measure the area under the curve.
Yes, yes, as well as this. But this is very difficult to calculate.
Okay.
I do this with my calculus class, not with the brief calculus, and we do the limit of this. For linear, quadratic, and cubic functions, we cannot do more. But in this class, I just want you to understand where this is coming from. I want you to understand this notation and be able to calculate the definite integral. Okay. Would you like to choose another? Or I will choose. Okay, so let's look at, I know we have, let me look at my phone. Only my phone gives me the exact time. Can you believe it? Sorry about that. So I want to choose a couple of other examples. Like, for example, the integral from a -2 to 3, negative x squared plus 4x minus 5 dx. So this is another integral. It's a definite integral. The answer has to be a number. So can anyone walk us through? I keep the minus in front. What function prime is x squared? Anyone?
Negative x squared over 2.
But when I differentiate x squared, I will not get x squared.
X cubed over 3.
X cubed over 3. Are we okay in agree? Are we all in agreement? What function I differentiate to get x?
X squared.
2.
Good. What function do I get? What function I differentiate to get 5?
5x.
That's it. From -2 to 3. What should I do next? Plug in 3 everywhere, and then subtract when I plug in -2 everywhere. So -3 to the third, 27 over 3, plus 2 times 9 minus 5 times 3. So this is the uppercase f of b, in our case is f of 3, minus, so whatever I write here is the uppercase f of a, which is in our case f of -2, and this is af. This is the most general antiderivative. So I plug in -2. It is safer to put parentheses because I have a negative from the formula, from the fundamental theorem of calculus. I have this negative, and I need to distribute it to everything that follows after it. So, there is a negative already. -2 to the third power is -8, another negative over 3. -2 squared, so it's 4 times 2, which is +8. And now, -2 times -5, which is +10. Calculations can be a little hairy. So -27 over 3 is -9. 2 times 9 is +18. And then -15 and minus. Careful. Minus with minus here will be 8 over 3, and then plus 18. So next, 18 minus 9 is 9. 9 minus 15, -6, minus 8 over 3, and minus 18. Least common denominator. Oh, let me just say -8/3 and then a minus 24 first. And then the least common denominator. So what is the least common denominator here?
3.
Yes. So then 24 gets to be multiplied by 3 as well. So this is -8 minus, is it 72? So this is -81. Is it? Divided by 3?
It's 80, right?
Oh, 80, yes, of course. -80 divided by 3. This is it. You can say, wait a minute. Can an integral be negative? Yes. An area can be negative as well. So if I have, for example, this graph, and I want to determine this area, this will be a positive area, this will be a negative area. Do you think that this tiny positive with this big negative, will it result into a positive area or a negative area?
Negative.
Yes. It will definitely be a negative area. Because the negative portion is bigger.